We're starting chapter 2, dynamics. Most of the concept in this chapter, we already have talked about it in grade 11 in the unit 2, forces. Here are key concepts based on Nelson grade 12 physics university preparation. After completing this chapter, you should be able to demonstrate an understanding how forces affect motion, solve two-dimensional motion problem, predict the motion of forces acting on a system of objects, explain advantage and disadvantage of friction, and conduct investigation and analyze technological devices and the applications of forces. Section 2.1, Forces and Free Body Diagrams. In order to understand motion, we should be able to describe it. In order to understand how forces will affect that motion, we should be able to describe forces. So forces are all around us, acting on every object that we can or cannot see. The motion of the cars, trucks, planes, boats are determined by the forces acting on them. We are always using forces to move around, to lift objects, to walk, etc. Forces are involved in every type of sport and activity. When we talk about kinematics, we said that kinematics is study of motion. So it is about moving object. However, we didn't focus on what causes the motion, because dynamics explain why objects move the way they do. One way to understand why an object moves is to study the forces acting on it. So dynamics is a study what caused the motion. So motion is about change. So change in position and sometimes change in velocity. So motion of the object that do accelerate. But what causes the acceleration? The answer is force does cause an acceleration. A force is a push or pull, and a symbol of force is capital F with a symbol of vector on top of it. The force is a vector quantity and has a magnitude and direction. Everything that you learn about vector applies to forces as well. The standard unit of force is a Newton and is labeled with a capital N. This unit, it is not a base standard unit, but it's a derived unit from meter, kilogram, and second. When we learn the second Newton law, you're going to see clearly that 1 Newton is equal to 1 kilogram times 1 meter divided by second square. So we have two types of forces. Contact force, the word says it all, is a force that acts between two objects when they are in a contact, when they touch each other. The non-contact force is a force that acts between two objects without the object touching each other. Also is called action at distance force. Force of gravity is a typical example of action at distance force. Understanding forces is essential for designing and developing technologies. Manufacturers, for example, car manufacturers, do a lot of tests to find out how forces will affect the car performance, car shape, etc. Forces can also distort matter by compressing, stretching, or twisting it. We're going to learn more about elastic forces this year in grade 12. Forces can speed up, slow down them, push objects around, lift them up, pull them down hills, or simply hold them still. So it is a lot to study about forces. We experience several types of forces daily. An obvious one is the force of gravity, which is the force of attraction between all objects due to mass. The force of gravity is directed toward Earth's center and symbol is Fg. The force of gravity is an action at distance force, which means that the contact between objects is not needed. Force of gravity is an attraction force only. It is responsible for keeping satellite in orbit. So force of gravity is equal mass time gravitational acceleration or gravitational field strength, which is 9.8 meter per second square down toward center of the Earth. We're going to learn a lot about gravitational forces and universal gravitational force and field in chapter 6 in this course. One important type of forces that we're going to learn is a normal force. Let's take a look. If the pen is resting on a desk, the force of gravity is pulling it down. But why is not falling down? So, of course, the desk is holding it. So the opposing force is the desk pushing it upward to cancel the force of gravity. This force is called a normal force. Normal because it's a perpendicular to a surface of the object in contact. The symbol is Fn with a N as a capital, but you might have seen this as a Fn with a lowercase n. So symbol is important. The normal force always points away from surface. So here is how we can draw a free body diagram, and we're going to talk later on about free body diagram. But force of gravity is the one as acting downward, and normal force is the one that is holding the object from moving toward center of the Earth. Friction is a force between objects in contact. It is a parallel to a contact surfaces and act in opposite direction to any motion or attempted motion. The general symbol for a friction force is Ff for friction force. Static force of friction is a force that prevents stationary object from starting to move. The symbol is Fs for static. So static, stationary. Object is not moving. Kinetic friction is a force that acts against the object motion. So object is moving, and force of kinetic friction act on against in opposite direction of the motion. The symbol is Fk. Air resistance is a friction that acts on an object moving through air. It becomes noticeable at a high speed. It is a special case of kinetic friction because the object moves through air. The air resistance symbol is Fair. Another type of forces is applied force, and tension is a special case. Tension is a force exerted by an object that can stretch, such as strings, ropes, fibers, and cables. Symbol is Ft or capital T. I recommend capital T because it's simple. Tension force is pull-only force and always point toward ends of the rope or a string. And obviously, you cannot push with a rope or string, so it is a pull only. An applied force is a force due to one object coming into contact with another, such that a push or a pull results. So it is a contact force. Symbol of applied force is Fa with a lowercase or capital A, but I recommend to be with a capital A. Applied force can be used as a general term for any contact force like normal, friction, or tension force. However, I do not recommend that. You can use applied force as a force that one object applies to another one. However, if you want to analyze a normal force or friction force, both those two forces are reaction force. Normal force is a reactive to force of gravity, and friction force is a reaction to a motion or attempted motion. So in the diagram below, it's a card that is pulled and pushed at the same time. Now you see a difference between using a tension force and applied force. When the object is pushed or pulled with a contact directly, then it's going to be an applied force. when the object is being pulled by a rope, string, cable, then is a tension force. Drawing force diagrams are very important. Two types of force diagrams that are used are system diagrams and free body diagrams. System diagrams is a drawing of all objects under analysis. So it's like a diagram or a picture to help you to understand the situation. It is optional, usually cannot be used to solve a problem. A free body diagram is a mandatory. It's a drawing in which only the object being analyzed is drawn, and is drawn with just a dot to make it simple, with arrows showing all the forces acting on an object. In a free body diagram, a positive direction is indicated, such as plus y for vertical and plus x for horizontal direction. As I mentioned, free body diagram is mandatory. So make sure that you draw a free body diagram on each problems that you solve. Otherwise, you may not get full marks. So to draw a free body diagram, you can actually have the coordinate axis x and y, get the positive direction for both of them, and then you can draw a dot. Very simple. And then draw forces that are acting on it and label it. Force of gravity is the force that always comes in your mind, and obviously it acts on all objects. Another one is a reaction force, which is called normal force. You label that as well. You have a diagram on the right, and you can draw a free body diagram on that as well. So there's an object, and it's pulled by two forces, and you can label the angles. Here are some couple of practice drawing free body diagram. Draw a free body diagram of the printer being pushed in a horizontal surface with a horizontal force. So printer is being pushed. We don't really know is moving or not moving. So we can draw a free body diagram with the force of gravity. We label it normal force and label it. And then is applied force, that is pushed force. And then it is a force of friction that is acting on it. If the printer is said that is moving, then the force of friction is going to be kinetic force of friction, so has to be labeled Fk. If the printer is not moving and is mentioned that is not moving, then you can label force of friction as Fs for static force of friction. Next one, draw a free body diagram of the sled being pushed in a horizontal surface with an angle force. So then you can draw force of gravity, a normal force, and you see that I draw a normal force not as above, because I know that this tension has a y component. So that means both of them, since that sled is not moving up and down, that both of those y component of the tension and normal force has to be equal with force of gravity. So you can draw a kinetic force of friction because the sled is moving, and then you can draw a component of that force Ty and Tx, and now you see that Tx has to be drawn almost the same length as a Fk, because then the sled is moving at a constant velocity. And as I said, sum of Ty plus Tn and Fn has to be equal to Fg. So we can draw a free body diagram of that object, or on the left, see that is not a horizontal surface, is inclined surface at a certain angle. Then you can draw x-axis along that surface and y-axis perpendicular to x-axis or perpendicular to that surface. And then draw a free body diagram with a force of gravity, and then normal force and label it, then tension and force of kinetic friction. But since that Fg is not an x and not on the y-axis, you can resolve that into component, Fgx and Fgy, and you label it. And that's a free body diagram of the object. Next one is a cart is pulled and pushed by two kids. Then you can draw the free body diagram with the force of gravity and normal force. They are the same length because they are pretty much canceling each other. The cart is not moving up or down. And we have applied force and tension. And then on the other side is force of friction. You can use Fs if that is not moving, or Fk if that is moving. That is a rolling friction, by the way. So that is another type of friction. But anyway, that's a force of friction will do it. Here are some more. Draw a free body diagram of the book at rest on the top of the desk. So it's a force of gravity acting on it. And since that book is at rest on the top of the desk is holding it, and a normal force is applying. So they cancel each other. So they are same length, same magnitude, opposite direction. They cancel each other. Draw a free body diagram of the basketball fall through a hoop. Ignore air resistance. That means that the only force acting on that basketball is a force of gravity. Next one. Draw a free body diagram of the large trunk is pushed horizontally from behind toward the east across a rough floor. A rough floor, that means it's a force of friction involved. Again, force of gravity, normal force, but then that's applied force and force of friction. Here is some practice using calculation. Determine the force of gravity acting on each object. A 2-kilogram object falls straight down. So what is given there is a mass. And although that is not given, gravitational acceleration is assumed it's given. What is required is a calculate force of gravity. So we know the formula to calculate the force of gravity, which is a mass time acceleration. So mass is 2 kilograms and acceleration is 9.8 meters per second squared down. So the force of gravity would be a 19.6 Newton downward. Next one. A person stand on the floor. So stand on the floor, that means it's a force of gravity and it's a normal force. What is given? Mass of the person is 62 kilograms and gravitational acceleration is 9.8 meters per second squared down. Force of gravity is mg, that is 62 times 9.8 is a 607.6 Newton down. Here is a summary of 4 fundamental forces, characteristics, and ranges. If you take a look there, gravitational force is a relative one, and look at the other 3 with the 20 zeros, 38 zeros, and 25 zeros. That makes those electromagnetic strong or a weak nuclear force very, very, very strong compared to a gravitational force. Take a look at the range. For a gravitational force and an electromagnetic force, the range is infinite. That means that those two objects, two charges or two magnets, will attract or repel no matter how far they are from each other. Gravitational force is attraction only, while the rest are to attract and repel. And I want you to focus your attention now to the range of the strong nuclear force. It is the size of the atom. And a weak nuclear force is a size of a nucleus of the atom. So that means that it's so small a range when they applies. Beyond this range, that strong force disappears, doesn't even exist anymore. So that's why when a nucleus disintegrates, then the huge amount of force and energy is actually released. That's why the nuclear reaction actually produces a lot of energy, and nuclear bomb or anything that you can imagine about nuclear energy. In order to determine F-net in two-dimensional, you do the same thing as we did already for any vector quantity for displacement in two-dimensional or velocities in two dimensions. Once you identify all forces acting on object, you can calculate the net force on an object or sum of all forces acting on an object. The symbol for a net force uses F net is equal F1 plus F2 plus etc. We often find X and Y component of F net and then calculate net force using Pythagorean theorem and tan -1 to get its direction. Same way that we did for total displacement or total velocity or relative velocity. So F net X is equal F1X plus F2X plus etc. etc. And F net Y is equal to all Y component of the forces. And then we draw it, F net X and F net Y. And then we draw F net and angle theta, use a Pythagorean theorem to find magnitude of F net and tan -1 to find direction of the angle of the F net. Or instead of F net, you use sum of all forces symbol. So this sum of all forces symbol is widely used in grade 12, as F net is used in a grade 11. However, those are interchangeable. You can use whatever you want. Sum of all forces or F net. That's the same idea. Now we have some practice problem using sum of all forces or as a F net. It's the same thing. Calculate the net force when each set of forces act on the same object. Draw a free body diagram for each object. So we have three forces, 5.5 Newton west, 3.4 Newton west, and 4.2 Newton east. You can draw this, and then you can find sum of all forces is equal minus 5.5 Newton, because west is negative, plus minus 3.4 Newton, which is west again, because west we chose to be negative, and 4.2 Newton, which is positive because it's east. So the answer will be minus 4.7, negative 4.7 Newton. So that is 4.7 Newton west. Next one is a 92 Newton up, 35 Newton down, 24 Newton down. And then you can draw that free body diagram, and you can find sum of all forces. And this is positive because it's up 92 Newton. and two negatives, so 35 Newton and 24 Newton. So the answer would be positive 33 Newton. That means 33 Newton up. Here's another one. We have four forces this time. 15 Newton up, 15 Newton down, 35 Newton east, and 12 Newton west. You can draw it. And then sum of all forces on x-axis is 35 Newton is positive, is east, and 12 Newton is west, is negative. The sum of all forces on x-axis is plus 23, that means is east, 23 Newton east. And on a y-axis is plus 15 minus 15, they will cancel each other, and we have 0. On the y-axis we have 0. Then net force on y-axis is 0, but on the x-axis is 23. That makes that net force on both axes is 23 Newton east. Here's another practice problem. A chain exerts a force of 1200 Newton up on a beam which experiences a force of gravity of 1100 Newton down. Draw a free body diagram on a beam and determine the net force on a beam. So, force of gravity and applied force. Then you choose positive direction up as a traditional and negative direction down. And then sum of all forces is equal to a plus 1200 Newton plus minus 1100 Newton. That will give you plus 100 Newton up. Here's the last practice for this lesson. You push a book across the table to your friend with a force of 6.5 Newton east. The force of friction on a book is 4.5 Newton west. The normal force and force of gravity have the same magnitude of 7.5 Newton. Draw a free body diagram of the book and calculate the net force. So you can draw up and down 7.5 force of gravity and normal force, and you have applied force on a east direction 6.5 and force of friction 4.5 on a west direction. So sum of forces on x-axis, we choose east as a positive. So it's a plus 6.5 plus minus 4.5 will give you plus 2 Newton. That means that 2 Newton east. Then on a y-axis, they are all the same. One is positive, is up, 7.5 up, positive, and the down is negative. They cancel each other. The sum of forces on a y-axis is 0. So the net force is just that force that was on x-axis. So net force on a y is not having any effect at all. So net force is 2 Newton east. That's about it for this lesson. Have a good one, guys.